This is part 2 of practice midterm number 1 and problems 41 through 44. The following gas phase reaction is carried out at 1 atmosphere of pressure. C5H12, which is pentane gas, plus 8 O2s, which is oxygen gas, react or transformed into 5 carbon dioxides gas, or CO2, plus 6 H2Os gas, which is water. This is, we want to classify each of the following statements as A, true, or B, false. Now, 41. The volume of the products is 6/8 times the initial volume of the reactants. Well, since it's carried out at 1 atmosphere of pressure and the pressure is maintained at a constant level, the volume would have to change. And this goes to Avogadro's law, which is that equal volumes of gases at equal temperatures and pressures contain equal numbers of molecules. This is a key law. And so that would mean that this is all prescribed by the ratio of product gas to reactant gas. And that we can count by the stoichiometric coefficients. It's independent of the identity of the gas. And so we have 6 and 5 is 11 moles of gas produced for every 9 moles of reactants. So it's actually going to be 11 ninths, which in no way equates with 6/8. So that means this is false. B. Now, number 42. There are 30 CO2 molecules produced for every 6 pentane molecules consumed in the reaction. When I say pentane, I mean C5H12. Okay. Now, in order to answer this question, this information is all going to be obtained from the balanced equation. And we're going to have to do a little dimensional analysis. So on a piece of scratch paper, I just used this scratch paper over here a minute ago, but I'm going to have to go over here onto my scratch paper to work out the details. I'm asking how many CO2 molecules are produced for every 6 pentanes used. So I'm going to start on the left-hand side with 6 C5H12. And now I look at the balanced reaction, and I have to know how many carbon dioxides. And it turns out the mole ratio of carbon dioxide is 5 CO2 for every 1 C5H12. So there are 5 carbon dioxides for every 1 pentane produced. And that obviously, the units work out nicely, it's dimensional analysis, and just one more application of it. 6 times 5 equals 30 CO2s. So, indeed, this problem 42 is true. Hey. And now, number 43. There are 108 grams of H2O, which has a molecular weight of 18 grams per mole for the purposes of this problem, produced for every 72.15 grams of C5H12, or pentane. Molecular weight equals 72.15 grams per mole, consumed in the process. So this is another exercise with significant figures. Dimensional analysis using the balanced equation. Okay? It's not a significant figure problem. And so I'll get my scratch paper out and work it out. Now, I'm asking, there are 108 grams produced for every 72.5 grams consumed. So I'll start on the reaction side. So I'm going to have to start with the pentane. And I have 72.15 grams of pentane. And there's 1 mole of pentane for every 72.15 grams of pentane. And now I'm going to need to go from moles of pentane to moles of water. I'm going to need the mole ratio, which we find in our balanced equation. And it turns out that there are 6 water molecules for every 1 pentane. C5H12. And now I'm in moles. Oh, I should, even though this is scratch paper, let's not take shortcuts. 6 moles of H2O for every 1 mole of pentane. Okay. Had to fix that. Now I'm in moles of water, but the question asked me grams. So now I'm going to have to use the other factor. It was provided information. There are 18 grams of H2O for every 1 mole of H2O. So my units work out. And so I started out with grams of pentane. I ended up in grams of water. I had to do a little bit of dimensional analysis, and it's a very straightforward process. Now let's just walk through the calculation. I didn't even have to revert to scientific notation. We're going to find in a little while how much simplification arises when we do so. But in this case, I didn't even need to. 72.15 divided by 72.15 is 1. And 6 divided by 1 is 6. So 1 times 6 is 6. And 18 divided by 1 is 18. 18 times 6, well, I got to go over and use my scratch paper. I have 18 times 6. And 6 times 8 is 48. And 1 times 6 is 6, and 4 is 10. Equals 108 grams of H2O, which is the desired units. Now, let's look at the problem. Oh, turns out that 108 was what was projected, so that is indeed a true statement. So we're going to, on these problems, we're going to need to work a little bit out on scratch paper. You could do this one in your head, but I'd advise you to work out a little hard copy on the side to help you keep from missing a factor, and do it in full detail. But it's on the scratch paper. I'm not going to see this. I am going to see this.